Hello students! So this video here is about solving quadratic equations by graphing. In this video I'm not going to do a whole lot with actually graphing quadratic equations because there'll be more lessons about graphing quadratic equations. In this particular lesson here, I'm mainly just going to go through some of the basics of graphing and some of the basic components with graphing to make sure that you can identify what you need to identify from the graph, and then I'm going to show you how to use certain graphing technologies and websites to actually solve these quadratic equations by graphing. Okay, so as most of you probably, I'm sure, remember, this is the real coordinate plane. And if you remember, you see these two very, very bold and dark lines there. As you remember, there are two components that are involved in the real coordinate plane. And again, for every coordinate, there are two components. There's the x values and the y values, right? And so first thing that you guys need to remember about using the real coordinate plane is which one of these is the x-axis, which one is the y-axis, right? And again, I'm going through this because when we're using this technology for solving quadratic equations, you need to know. Otherwise, you're not going to be able to solve quadratic equations by graphing. So I just want to make sure that you've got the basics, even if some of you do already remember this. So again, you should remember that the x-axis is the axis here that is horizontal. That bold line in the middle that is going from the left to the right. You should remember that one is the x-axis. Alright, so you should remember that this one is your x-axis, and along that x-axis, if we were going to label the x-axis, remember that each little place there, 1, 2, 3, 4, and it goes on 5, 6, 7, 8, and then so on the right side we've got these positive x values like 1, 2, 3, 4. On the left side of this graph, we've got negative x values, negative 1, negative 2, negative 3. Again, that's the x-axis. So again, this x-axis here, it labels your x values from left to right. And as you can see here, it is the axis, that line that you see that I have made red. Okay, that I've outlined in the color red. So that's the x-axis. That's one component. These x values that go from left to right. That's one component that you got to know about when you're dealing with coordinates in the real coordinate plane. The other component that we need to make sure we know about are the y values. And again, your y-axis, that is this vertical line here in the middle. And that y-axis, again, that just labels your y values from the bottom to the top, from top to the bottom. That just labels what your y values are, because again, y values they go from up and down. They go from the bottom to the top. So again, folks, as you can see, we've got the y-axis here, color-coded in blue, and again, that is the axis that labels the y values from the bottom to the top. And again, the negative y values are at the bottom, and the positive y values are at the top. So we're going to make sure, just real quick, we're just going to make sure that you guys know how to do the basic thing of graphing a coordinate point or an ordered pair. Let's say that, for instance, we were asked to graph something like the point -2, 5. And so if we were asked to graph that point there, first you need to realize that for any type of ordered pair, because that's what this is, it's a coordinate point, it's an ordered pair, there are two components to this ordered pair. One of them is the x value, and so remember that the ordered pairs are always in this form. The x value is the first number, the y value is the second number. And so if we were going to graph that ordered pair, the x and the y value, there's only going to be one point that's going to be the result of doing this. I've seen students who did not know how to do this, and when they were asked to graph an ordered pair, this is the most basic thing with graphing things. They were, and what they did mistakenly was they put two different points for just one ordered pair. And again, that would be a mistake, because even though there are two components, when you graph this, there's only going to be one point. So again, we're just going to make sure that everybody knows the basics here. So again, the x value here is -2. And so remember that for the x value, x values only go from left to right. And again, what that means is that if it is a, oh, and by the way, first off, guys, where the y-axis and the x-axis, where they intersect, or that place directly where they overlap, that place is known as the origin. So where you see where I've got this green dot right here, that is known as the origin. Okay, and that origin, that point is 0, 0. So that origin, that point there is 0, 0. But again, folks, we're not even talking about graphing the origin, but that point that I've got there right now in green, that is where we're going to start. That is always where you start when you're trying to graph an ordered pair. At that origin, 0, 0 is right there in the middle, is where both the x-axis and the y-axis meet. And so that means that you have not moved up or down, and you have not moved left or right yet. So again, when we're looking at the x component, if you have a negative number, that means that you are going to be moving to the left. So again, folks, if we're saying that you need to go left if the x value is negative, then clearly the opposite of that is true. If this x value was a positive number, then you would need to move to the right. Okay, but again, I'm not going to write that because that should sort of be common sense if I'm saying that negative is moving to the left and positive is moving to the right. Okay, so when we look at this y value here, the y value, that is going to determine your up or down motion from the origin. And again, the origin, that point 0, 0, that is where we start. When we look at the y value, it's +5 here. So you're going to move up if the y value is a positive number. Alright, so clearly, guys, and again, for the y value, clearly, if that y value is positive, we move up. Then obviously, if the y value is negative, then we're going to be moving down, right? So let's put it all together with this ordered pair. And again, some of you might be thinking, okay, well, this is just way too basic, Mr. Starkey. That's exactly how we want it, because I don't want you to have any excuse for knowing how to do this. All right, so let's put it all together. Let's graph this one point, this one ordered pair here. And so again, that one ordered pair of -2, 5. So if we start at the origin, if we start at that where you see this green dot right now, you only want to make two motions. You want to move left 2 from this green dot. So if you move left 2, that's 1, 2, and you also want to move up 5. So again, there's going to be two motions. You're going to move from this origin, the 0, 0. You're going to move left 2. So if you count that, that's 1, 2, and you're going to move up 5. That's 1, 2, 3, 4, 5. So this point here will wind up being, again, and if we do it from the origin, that is us moving left 2, 1, 2, and up 5. So this point here is negative 2, 5. And again, you can see that from the origin, that point in the middle, we've gone left 2 and up 5. And notice, even though we moved in 2 different directions, there's only one point that is the result of graphing this. You should not have 2 points graphed. So that was just a little bit of basics with graphing. And again, just to check to see what you got from that. Let's see if you guys can identify exactly what the ordered pair is for this point here. Can you identify what the ordered pair is for this one? Okay. So again, folks, if you had to identify what the ordered pair is or what that coordinate is, because again, this is the most basic thing with graphing. If I'm even asking you to look at a graph of something and to tell me specific points from it, if you can't do that, then we've got a problem with moving forward. Okay. So again, let's see here. For this point that I've just put here, if you want to identify what the ordered pair is, again, start from the origin. And again, that's this green point that I've got here on this graph right here. And again, I do hope that everybody already knows what the origin is. But again, in case you don't, that's why we're making this video here. So, if we will count exactly how far to the right or to the left this point is from the origin. So let's see, I'm going to start counting. So I'm starting here at the origin. I've got my mouse there so you can see that too. I'm going right 1, 2, 3, 4, 5, 6, 7, 8, 9. I've gone 9 places to the right. So that was 9 places to the right, which means that my x value is 9. Positive 9. And again, that was from the origin, from that point in the middle. In order to get to this particular point, I've gone 9 units to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that was the right or left component for this point. Then for the up or down component, which is the y value, I have to go down. And let's count how many that is. That's 1, 2, 3, 4. Since I'm going down here, that means that this is going to be a negative y value. Okay, so again, that was 1, 2, 3, 4. That's down 4. That means that this y value is negative 4. So again, for this particular point that you're seeing right here, this coordinate here is 9, negative 4. Because from the origin, you had to go right 9 and down 4 in order to get to this particular point. But again, it is just one point, even though it has 2 components. Okay, so now let's get into the meat of this actual lesson here. So here's the question. Where are the solutions on the graphs of quadratic equations? So where are those solutions actually located? If we actually have the graphs or the graph for a quadratic equation, where's that solution at? And how are we going to locate that? And so I'm glad you guys asked that, actually. So when you're looking at the graph of a quadratic equation, the place where you want to look for solutions, and there can be more than one solution, is you want to look for x-intercepts. So, and that's basically the whole point here of this lesson, being able to identify those solutions for a quadratic equation using graphs. And so we're not even going through the details of how to graph the quadratic equation, but just seeing if you can look at the graph of a quadratic equation and identify what the solutions are based on looking at the graph. And in order to do that, you have to be able to identify the solutions, which are the x-intercepts, or at least those are the real solutions, the x-intercepts. So for those who may not know what an x-intercept is or what an x-intercept looks like, I just want to do a little basic little thing showing you where to identify the x-intercepts. You'd be surprised at how many people might not know. So again, as a reminder to you guys, because this should be a review, x-intercepts are specific points, and by points we mean ordered pairs. So x-intercepts are specific points on the x-axis that are intersected, and by intersected we mean touched or crossed. So again, x-intercepts are specific points on the x-axis that are intersected by a graph. So let's look at what it looks like when we're identifying x-intercepts on a graph. So here, I'm just going to put a random graph here, and this is not even the graph of a quadratic, but I'm going to do this in blue. I'm just going to put some random graph here on this coordinate plane. Some random old graph here. You see that? I'm even going off the coordinate plane. Alright, so when you're looking at this graph, and it's in blue here, I just went all over the place because there's only one place that we're going to be looking for x-intercepts. And so you're going to be looking for x-intercepts to be those places on this graph where it actually touches or crosses the x-intercept. I'm going to let you guys see my little ruler here. This is how I do straight lines. So, for those who, you should already know where the x-axis is. The x-axis, again, as we explained a few minutes ago, is that bold line that's in the middle that's going from the left to the right. So, if we look at this x-axis here, and if we go ahead on, and I'm just going to highlight what this x-axis is. So again, you can see that x-axis. I'm highlighting it for you. Okay? There are only certain places where this x-axis is touching or intersecting, touching or crossing that graph, that blue line, that blue graph is really not a straight line, but there are only certain places where the x-axis is actually touching that. And so, if you follow along that blue line, okay, oh, well, what is that? Look at this place. That blue line just touched or crossed the x-axis. That's an x-intercept. Alright, let's keep going along the blue line. Oh, what is this? The blue line just touched or crossed the x-axis. This point is also an x-intercept. Oh, let's keep going along. Oh, my blue line just touched or crossed the x-axis. That's an x-intercept. And oh, what is this? My blue line just touched or crossed the x-axis here. So on this particular graph here, there happen to be 4 x-intercepts. Okay, so there are 4 x-intercepts on this particular graph here. Again, I just wanted to go through how to identify those x-intercepts if you were unsure. And again, this should be a review because most of us should already know what x-intercepts are and how to identify them. Those 4 points are x-intercepts. And again, on the specific technology that I'm going to ask you guys to use, it's going to be very, very easy for you to actually tell what the ordered pairs are for these x-intercepts. Okay, so I'm getting ready to go ahead on and go to that specific technology that I'm going to ask you guys to use, the one that's going to be the easiest for you guys to use. And so some of you may or may not have heard of what is it called, Desmos graphing calculator. This is something that you can do whether you're on a computer or whether or not you're on your phone. If you're on a computer or a laptop or whatever, you can go to Google, go to your little Google machine and type in Desmos graphing calculator. and it'll pull it up from Desmos.com. If you're on a phone, whether that's an Android or an iPhone, they've got an app for Desmos graphing calculator. All you have to do is look for this particular, where is it at? Look for this logo right here that you're seeing on this screen. You see it? You see the logo? It's green with these little white squigglies on it. You see it? So if you want to do it on your phone, there's a Desmos graphing app that you can do on your phone, and it should be available on both iPhones and Androids. So, but again, I'm on a computer, so I'm going to pull this up from my computer on Desmos.com. And again, all you got to do is Google Desmos graphing. So when you do that, it pulls up this great, awesome graphing technology that you can use. And so, and I'm just going to show you this very, very quickly. Let's just say, for instance, that the particular quadratic equation that we need to solve by graphing, let's just say that this one is y equals x squared. So if you're not sure how to type in x, okay, just where it says here, show keypad. Okay, I don't know if you guys see that little thing down here that looks like a little keyboard. Okay, I'm clicking on that. Oops, if I can get it to work. Hold on. There we go. Alright, so x squared. So you can see immediately, as soon as I typed in something, it automatically starts graphing it. Okay, so it does it in real time for you. So that's x squared. Let's say that we're doing x squared minus, let's just pick a random thing, x squared minus 5x plus, or let's do minus, well no, plus 1 or something like that. Okay, so let's just say that you were trying to solve this particular equation by graphing. You saw immediately when I typed it in, it automatically shows the graph. You can zoom in on the graph, you can zoom out on the graph. If you're on your phone, of course you guys know how to zoom in or zoom out on your phone if you're not seeing what you need to see. So on this thing here, you can either type it in with the y equals, or I'm just going to show you, it still graphs it even if you don't type the y equals. It still graphs this thing. This thing is awesome. So we got the graph of y equals x squared minus 5x plus 1. And I've explained to you now that when we are solving these quadratic equations by graphing, you are really looking for the real solutions as x-intercepts. So you guys should recognize which one of these lines here, and I know you're seeing all these grids up here. You should recognize which one of these lines is the x-axis. Now I don't have to put a separate line up here for the x-axis, but I am going to show you that though. Just give me a sec here. So it will allow you to put as many graphs up here as you need to. For those who may not be able to look at this and tell, oh my goodness, there's so many grids up here, Mr. Starkey, which one of these is the x-axis? For those of you who may not be able to tell which one is the x-axis, I'm going to put a second graph up here, and you can do that on whatever type of device you're doing too. And I'm going to put it up here as y equals 0. So did you see that? You saw that green line there immediately appear? That green line that appeared, and it just so happens to be green on this particular graph here. That green line that appeared here, that is the x-axis. The x-axis there, okay? That y equals 0. That's the same line. That is the same line as the x-axis, y equals 0. So again, for those who may not have been able to tell by looking at all of these grid lines, you may not have been able to tell which one was the x-axis. There you go. If you put in y equals 0. So now you can see this green line, that's the x-axis, and you can see the blue graph here. That was the graph that we were looking at. So we are looking for the x-intercepts. We're looking for those particular points on the x-axis where the graph actually touches or crosses it. And if you look closely, or at least on this computer that I'm using, it already has certain points. It has certain points already sort of kind of there. I don't know if you can see that. You may or may not be able to see that. I don't know if you can already see that, but there are certain points that are already there, and all you have to do is really just click on those. So, and make sure you click in the right place. I'm going to zoom in so we don't click something by mistake. So, you see here, you see that it's already sort of there, but if I click on it, look at that, it became a dark point now, and now I can tell exactly what that point is. That is the ordered pair of 0.209 as the x value and 0 as the y value. And then I can do the same thing for this particular place here, where this graph, the blue graph, is intersecting or touching or crossing the x-axis. So it should be fairly easy for you to use Desmos graphing calculator, graph the graph that they're telling you about, and for you to point out those x-intercepts. This is an x-intercept here, and this one is, so for this particular graph, there are only 2 x-intercepts that are there. Okay? These 2 here. And so, if you're on Delta Math, the Delta Math problems that I've assigned here that you'll see, they say find the zeros of the function blankety blankety blank blank blank. So again, what I didn't tell you yet was that these x-intercepts for quadratic equations, another name for them is zeros. So again, Delta Math is going to call them zeros, and again, you'll probably hear me in the future calling them zeros, and you'll also hear me saying another name for them, which I'm not going to say right now, but again, they're also called zeros, these solutions, the real solutions, these x-intercepts. So again, on Delta Math, they are saying here, find all the zeros for this function to the nearest 100th value. So if you're doing it to the nearest 100th, you want to make sure that you include 2 of the decimal places after 2 decimal places after the, or 2 places, 2 numbers after the decimal. Okay. So for this first x-intercept here, this first 0 x-intercept, if you were rounding that to the nearest 100th, this would be 0.21. And again, it would be 0.21 because we would have to round this up to the nearest 100th value. Okay, and this other answer here would wind up being 4.79. All right, and so we would round this one down to 9 because again, that number that comes after that is lower than 5, is less than 5. All right. So I do hope that this video has been helpful to you. Again, I've shown you and explained to you what the solutions are when you're looking at the graph of a quadratic. The solutions are an x-intercepts. And again, I've shown you how to use Desmos graphing calculator. It should be fairly simple for you to graph a quadratic equation using Desmos. And for this particular lesson, that's really all I'm requiring you to do. And you can look at that and identify what are those x-intercepts on this quadratic graph. Alright? And so I do hope that you've gotten something out of this lesson. I was going to show you how to find these same solutions on a TI-83, TI-84 calculator. But again, for this particular problem or this particular lesson, you can do everything that you need to do on Desmos graphing calculator, and it's going to be the easiest way for you. So that's all, folks. That's all.